images taken in January 1946 by a U.S. Marine photographer. Some scientists estimate that a nuclear war with 100 Hiroshima-size nuclear explosions on cities could cost the lives of tens of millions of people from long-term climatic effects alone. The climatology hypothesis is that if each city firestorms, a great deal of soot could be thrown up into the atmosphere, which could blanket the Earth, cutting out sunlight for years on end, causing the disruption of food chains, in what is termed a nuclear winter. 87, 88. People near the Hiroshima explosion and who managed to survive that explosion subsequently suffered a variety of horrible medical effects. Some of these effects are still present to this day. Sad Smiley 89. Initial stage: the first 9 weeks, in which are the greatest number of deaths, with 90% due to thermal injury or blast effects and 10% due to superlethal radiation exposure. Intermediate stage from 10 to 12 weeks. The deaths in this period are from ionizing radiation in the median lethal range LD50. Late period lasting from 13 to 20 weeks. This period has some improvement in survivors' condition. Delayed period from 20 plus weeks. Characterized by numerous complications, mostly related to healing of thermal and mechanical injuries, and if the individual was exposed to a few hundred to 1,000 millisieverts of radiation, it is coupled with infertility, subfertility and blood disorders. Furthermore, ionizing radiation above a dose of around 5,100 millisievert exposure has been shown to statistically begin increasing one's chance of dying of cancer some time in their lifetime over the normal unexposed rate of 25%. In the long term, a heightened rate of cancer, proportional to the dose received, would begin to be observed after 5+ years, with lesser problems such as eye cataracts and other more minor effects in other organs and tissue also being observed over the long term. Fallout exposure: depending on if further afield individuals shelter in place or evacuate perpendicular to the direction of the wind, and therefore avoid contact with the fallout plume, and stay there for the days and weeks after the nuclear explosion. Their exposure to fallout, and therefore their total dose, will vary. With those who do shelter in place, and or evacuate, experiencing a total dose that would be negligible in comparison to someone who just went about their life as normal. 90, 91. Staying indoors until after the most hazardous fallout isotope, I-131 decays away to 0.1% of its initial quantity after 10 half-lives, which is represented by 80 days in I-131's case, would make the difference between likely contracting thyroid cancer or escaping completely from this substance depending on features of the individual. 92. Effects of nuclear war. Mushroom cloud from the explosion of Castle Bravo, the largest nuclear weapon detonated by the U.S. in 1954. Nuclear war could yield unprecedented human death tolls and habitat destruction. Detonating large numbers of nuclear weapons would have an immediate, short-term and long-term effects on the climate, potentially causing cold weather known as a nuclear winter. 93, 94. In 1982, Brian Martin estimated that a U.S.-Soviet nuclear exchange might kill 450 million directly, mostly in the United States, Europe and Russia, and maybe several hundred million more through follow-up consequences in those same eras. 95. Many scholars have posited that a global thermonuclear war with Cold War era stockpiles, or even with the current smaller stockpiles, may lead to the extinction of the human race. 96. The International Physicians for the Prevention of Nuclear War believe that nuclear war could indirectly contribute to human extinction via secondary effects, including environmental consequences, societal breakdown, and economic collapse. It has been estimated that a relatively small-scale nuclear exchange between India and Pakistan involving 100 Hiroshima yield 15 kilotons, weapons could cause a nuclear winter and kill more than 1 billion people. 97. According to a peer-reviewed study published in the journal Nature Food in August 2022, a full-scale nuclear war between the US and Russia would directly kill 360 million people and more than 5 billion people would die from starvation. More than 2 billion people could die from a smaller-scale nuclear war between India and Pakistan. 94, 98, 99. Public opposition. Protest in Bonn against the nuclear arms race between the U.S./NATO and the Warsaw Pact. 1981 demonstration against nuclear testing in Lyon, France. In the 1980s. Peace movements emerged in Japan, and in 1954 they converged to form a unified Japan Council against atomic and hydrogen bombs. Japanese opposition to nuclear weapons tests in the Pacific Ocean was widespread, and an estimated 35 million signatures were collected on petitions calling for bans on nuclear weapons. 100. In the United Kingdom, the first Aldermaston March, organized the Campaign for Nuclear Disarmament, CND, took place at Easter 1958, when, according to the CND, several thousand people marched for 4 days from Trafalgar Square, London, to the Atomic Weapons Research Establishment close to Aldermaston, in Berkshire, England, to demonstrate their opposition to nuclear weapons. 101, 102. The Aldermaston marches continued into the 1960s when tens of thousands of people took part in the 4-day marches. 100. In 1959, a letter in the Bulletin of the Atomic Scientists was the start of a successful campaign to stop the Atomic Energy Commission dumping radioactive waste in the sea 19 kilometers from Boston. 103. In 1962, Linus Pauling won the Nobel Peace Prize for his work to stop the atmospheric testing of nuclear weapons, and the bomb movement spread. 64. In 1963, many countries ratified the Partial Test Ban Treaty prohibiting atmospheric nuclear testing. Radioactive fallout became less of an issue and the anti-nuclear weapons movement went into decline for some years. 81. 104. A resurgence of interest occurred amid European and American fears of nuclear war in the 1980s. 105. Costs and technology spin-offs. According to an audit by the Brookings Institution, between 1940 and 1996, the U.S. spent $10.9 trillion in present-day terms, 106, on nuclear weapons programs, 57% of which was spent on building nuclear weapons delivery systems. 6.3% of the total, $681 billion in present-day terms, was spent on environmental remediation and nuclear waste management, for example cleaning up the Hanford site, and 7% of the total $763 billion was spent on making nuclear weapons themselves. 107. Non-weapons uses. Peaceful nuclear explosions are nuclear explosions conducted for non-military purposes, such as activities related to economic development including the creation of canals. During the 1960s and 1970s, both the United States and the Soviet Union conducted a number of PNEs. 6 of the explosions by the Soviet Union are considered to have been of an applied nature, not just tests. The United States and the Soviet Union later halted their programs. Definitions and limits are covered in the Peaceful Nuclear Explosions Treaty of 1976. 108, 109. The Stalled Comprehensive Nuclear Test Ban Treaty of 1996 would prohibit all nuclear explosions, regardless of whether they are for peaceful purposes or not. 110. History of development. In nuclear fission, the nucleus of a fissile atom, in this case, enriched uranium, absorbs a thermal neutron, becomes unstable and splits into two new atoms, releasing some energy and between 1 and 3 new neutrons, which can perpetuate the process. In the first decades of the 20th century, physics was revolutionized with developments in the understanding of the nature of atoms, including the discoveries in atomic theory by John Dalton. 111. Around the turn of the 20th century, it was discovered by Hans Geiger and Ernest Marston and then Ernest Rutherford, that atoms had a highly dense, very small, charged central core called an atomic nucleus. In 1898, Pierre and Marie Curie discovered that pitchblende, an ore of uranium, contained a substance which they named radium that emitted large amounts of radiation. Ernest Rutherford and Frederick Soddy identified that atoms were breaking down and turning into different elements. Hopes were raised among scientists and laymen that the elements around us could contain tremendous amounts of unseen energy, waiting to be harnessed. In Paris in 1934, Irene and Frederick Joliot-Curie discovered that artificial radioactivity could be induced in stable elements by bombarding them with alpha particles. In Italy, Enrico Fermi reported similar results when bombarding uranium with neutrons. In December 1938, Otto Hahn and Fritz Strassmann reported that they had detected the element barium after bombarding uranium with neutrons. Lise Meitner and Otto Robert Frisch correctly interpreted these results as being due to the splitting of the uranium atom. Frisch confirmed this experimentally on January 13, 1939. 112. They gave the process the name fission because of its similarity to the splitting of a cell into two new cells. Even before it was published, news of Meitner's and Frisch's interpretation crossed the Atlantic. 113. In their second publication on nuclear fission in February of 1939, Hahn and Strassmann predicted the existence and liberation of additional neutrons during the fission process, opening up the possibility of a nuclear chain reaction. After learning about the German fission in 1939, Leo Szilard concluded that uranium would be the element which can realize his 1933 idea about nuclear chain reaction. 114. Uranium appears in nature primarily in two isotopes, uranium-238 and uranium-235. When the nucleus of uranium-235 absorbs a neutron, it undergoes nuclear fission, releasing energy and, on average, 2.5 neutrons. Because uranium-235 releases more neutrons than it absorbs, it can support a chain reaction and so is described as fissile. Uranium-238, on the other hand, is not fissile as it does not normally undergo fission when it absorbs a neutron. By the start of the war in September 1939, many scientists likely to be persecuted by the Nazis had already escaped. Physicists on both sides were well aware of the possibility of utilizing nuclear fission as a weapon, but no one was quite sure how it could be engineered. In August 1939, concerned that Germany might Leo Szilard, pictured in
Yes,
about
I have to stop the video.
1960, invented